Hello, my name's Paul and this is an overview of my doorbell ring detector project. Now, at least in the UK, a lot of houses still have kind of an old style traditional analog doorbell. And this is probably about the simplest circuit you can possibly imagine. You've got a 6 to 12 volt AC power supply, a doorbell switch, obviously at the door, and then a bell. And a very simple circuit there. So when you press the bell, when you press the switch, the bell rings. Now, obviously, that's got the advantage of being really simple, and there's very little to actually go wrong. But if you want to integrate that, say, into a Home Assistant setup or into some other smart home setup, you've got to do a little bit of work. Now, there's obviously some options as to how you can do that. Some of them involve having to replace the whole circuit, put a smart doorbell on or something like that. But I didn't want to do that. I wanted to be able to retain the old analog alarm, but also be able to detect the doorbell ring and then alert my Home Assistant setup. So in order to do that, there's a few options, but essentially the main one we have is that what we want to do is do something that detects the current when it's flowing through the doorbell circuit. There's some reasons we want to detect the current rather than the voltage, because it's just sort of slightly easier. It means you can put the whole thing on the power side of the switch rather than on the other side, the bell side of the switch. And obviously, the advantage of being on the power side of the switch is that usually the power will be sort of underneath the stairs or something like that. It's going to be much easier to be able to power a device there than it is at the doorbell or at the switch. So what we want to do essentially in the concept of the project is do some sort of Hall effect current sensor, put that in the doorbell loop, digitize that using a microcontroller, and I chose to use a ESP32C3, and then over Wi-Fi send an MQTT request update saying when the doorbell rings or not. So in order to do that, luckily you can get some quite nice little Hall effect current sensor ICs, and this is the ACS 7112, which is really the core of the project. And as you can see from the application note, what essentially do is you put that in line with the current, and then that generates an output voltage which is proportional to the current flowing in the circuit. So essentially then we're able to use that, take that output voltage, digitize it, and do some processing on the ESP32 and send our MQTT updates. So in order to do that, I wanted to be able to find a way of writing that firmware in a reasonably simple way. I chose to write the firmware in Rust using the ESB IDF, the standard toolkit, the ICE-HAL. And again, I won't go through the firmware in detail, but essentially we do the usual things of setting up our peripherals and configuring those. We then connect to our access point, and then when we've done that, set up an ADC task to digitize the output of the ACS7112, do some statistics on that, and then we sit in a loop looking for messages from the ADC task, and when we see a ring message, we then send an alert on that. So all fairly simple. So in order to be able to test that, we wanted to be able to kind of set up a fairly simple breadboard, and so this is the kind of breadboard I set up to be able to test that. The nice thing is you can get modules for quite a lot of the pieces on AliExpress, which means that you can prototype it really quickly. So what you've got there is you've got the doorbell transformer. From the doorbell transformer, we tap off a power supply, and that's a simple bridge rectifier and 7805 power supply that gives us 5 volts out to power both the ESP32 and the ACS7112. We then put the ACS7112 in line with the doorbell circuit, and you can see the sort of circuit goes from the power supply through the ACS7112 to the bell, to the button, through the bell and back, and obviously the ACS7112 then detects the current flowing. We take that current output and we bring it over to the ESP32C3, and this uses the ESP32C30, quite a nice simple little board with onboard Wi-Fi antenna that we can use to build the software. What we then want to do is obviously install the firmware onto the ESP32 and see if it actually works. So what I've got here is a just an MQTT viewer, and that's just showing what's being published, and you can see there you've got the doorbell, and you've got a couple of topics. You've got ring there, which tells us obviously whether it's ringing or not, and then just a couple of status displays, and those are updated every 30 seconds or so, and that just tells us what the IP is, so that's kind of useful to be able to set up and configure the device. And then it also sort of every 30 seconds so just sends us a summary of some of the stats it's seeing from the ADC. So that's telling us the mean value, basically what the quiescent value of the ADC is, and the standard deviations, how much noise there is on that. And the way we detect the ring is when the ring circuit is completed, what we'll obviously see is the AC sine wave going through the current detector, so we'll see quite a lot of deviation from the mean. So what we do is basically just look at the standard deviation and try and detect that. And so what we can do now, again, just set up on the board. If I do a test and ring the bell, what you can see there is you saw the bell, the ring indicator going on and off, and then obviously you can do whatever you want, either plug that into Home Assistant or just run an MQTT subscribe to do what you want for that. And then also you just got a little bit of statistics there, the ring stats, that just told you how the statistics changed when the device rang. So what you can see there is under normal cases you've got a standard deviation of like 0.0049, but when the doorbell rings you saw a standard deviation of 0.02. So obviously that's about 4 times the level, and that's what we detect. So at that point now we've got a kind of working prototype, and it's running and it's sending events, but obviously not very convenient to be able to kind of plug this in under the stairs of the wall. So we now need to do a bit of work to productize that. So obviously the first thing we want to do is go into KiCad and generate a custom PCB for that. So in KiCad, obviously, the kind of first thing we do here is generate a schematic. And what you can see is the schematic is pretty much exactly the same as the concept we saw earlier. We've got the power coming in from the power supply. We tap some of this off and just put it through a simple power supply. So you've got bridge rectifier there and capacitor to give us DC out, and then an LDO to give us 5 volts out. Which goes to the processor. We've got the current sense, we've got the ACS 712 module that sits in line with the power, power. So you've got power coming in through here, through that, and out. And then we detect that. We just put a little voltage divider there to make sure the voltage stays within level that the ESP32C3 can deal with. It's got a maximum ADC input of 3.3 volts, and that potentially goes to 0 to 5 volts. So we just split that in half there. And then we've got the SP32 there, ADC input connected up here, and then we can add a reset button and a status LED, a WS2812 status LED. So fairly simple schematic there, and so obviously the next step then is to lay that out on a PCB, and we obviously lay that out, fairly simple, nice 2-layer board. One of the things we do there is making sure that we don't put a ground plane underneath the ESP32 module, because obviously that would affect the Wi-Fi antenna. Now, in order to manufacture that, I chose to use JLCPCB. There's a really nice little plugin that works with KiCad that allows you to kind of make sure that you've got the BOM up to date, and you've got all the right components specified. Now, because it's a surface mount board, I wanted to get the board fabricated, as much board fabricated as possible. So I chose to submit this into LCSC with them doing basically all the surface mount components. Then I'd put the through-hole components on later. So with that, we're able to get a nice PCB fabricated, and there you can kind of see the power supply in, power supply out, going via the ACS 7112. Our little power supply here, the bridge rectifier, LDO, and then the ESP32 board goes on there. So obviously we need then to have some kind of box to put it in, and I chose to use OpenSCAD to try and create a box for this. And OpenSCAD, for those who've not used it, is basically a parametric 3D design tool. Allows you to put your own parameters in and basically generate a board from that. That's quite nice in that actually what this is a generic box designer. You can just set your parameters here and it will create a box for you, which you can then obviously go and print on your 3D printer. So finally then you can assemble that into the final case, and then it's just a matter of plugging that into your alarm circuit, and you can get a nice smart home notification or MQTT notification when someone rings your alarm. I chose to just put a basic subscription, MQTT subscription on this that would send me an alert on my phone, and then also take a picture, because I've got a camera by the door, to take a snapshot of who's at the door. So anyway, I hope you enjoyed the project, and certainly found it quite interesting, and it was really interesting to be able to put all the bits together. Thank you very much.